So this video is going to be about area and how to calculate it using various shapes. Each of those shapes are going to have a different formula, and it's really important that we memorize these or have them written down somewhere. So let's start off with a quick look at just what area is. Well, in the last lesson we went through perimeter, which we did by calculating the outside length. Now we want to look at the area. We want to look at how much space is inside of this rectangle. So here it says down the width that it's 2 meters, and so there's two lots of meters. Let's say one side that's 1 meter each, 1 meter each here, and then this one is 3 meters. 1, 2, 3. So we want to know how many squares are in there. Well, in this case it's 6. 6 meters squared. So you can just do 3 times 2 equals 6. This shape is, we should all know, is a square, and I know that because these dashes indicate that all the sides are the same length and all the angles are at 90 degrees. That means it's a square. To calculate the area of a square, all you need to do is times the length by itself. Length times length, otherwise known as length squared. This one is a rectangle, and I know that because I have two sides of different lengths. So this side is the same length as that, and this side is the same length as this one. It's the width and the length. We can calculate the area just by doing length times width. We should all know that this shape is a triangle, and to get to the area of a triangle, first of all you have to draw this imaginary line from the base to the apex at a right angle, and that is the height of the triangle. The longest side we generally call the base, and the area of a triangle is a half times the base times the height, or just simply the base times the height divided by 2. So now we're getting into a bit more of the advanced shapes. This is a rhombus, and it's not quite complete yet. I know it's a rhombus, one, because all the sides are the same length, as indicated by there. I also know it's a rhombus because, I'm going to put in now, the sides are parallel to one another. So I have a shape that has all sides are equal, and 2 of the sides are parallel, and the other 2 are parallel as well, but the angles are not at 90 degrees. So it's like a square that's been squished to the side, and this is what we call a rhombus. To calculate the area of a rhombus, we need to know 2 things. We need to know how long this length is from that corner to that corner, and we call, or can call, that x. And we also need to know the length from this corner to the other one, and we call that y. The area for this shape is a half times x times y, or x times y divided by 2. This shape is a parallelogram. It's much like the rhombus, except instead of being a square squashed to the side, it is a rectangle moved to the side. So it has lines of equal length on both the top and bottom, and they are parallel. And to figure out the area of a parallelogram, you take the height, which is any distance from the top to the bottom, and you times that by the base. Trapeziums are shapes that have a set of parallel lines in them. So just this one here and this one here. We normally call those lines A and B. Now the trapezium can have any angle here, it doesn't matter, it just has to have parallel lines. And we calculate the area using the formula half times the sum of A plus B times H. So what you'll do here first is that you'll add A and B together, okay, BODMAS, do your brackets, and times it by H, and then times by a half. Again, same as the previous ones, that can also be equal to H, we just move that to that side, A plus B divided by 2. Kites are a special shape that have two sets of lines that are equal length. It's a four-sided shape and they both are equal length. So this one is equal length to that one, and that one is equal length to that one. Again, we have to know the distance from one point to another. So from there, that's the x value, and up and down, that is our y value. And the area for a kite is a half times x times y. And if you've been following along, you'll know that that's the same as saying x times y divided by 2. Finally, for our special shapes, we're looking at the area of a sector of a circle. And much the same as the perimeter, you're using a ratio. So a circle can be divided into 360 equal parts, that's its degrees. And you want to know the ratio of what you have. So if you have something that looks like this, you know you have a quarter. So you will have, well, it's 90 degrees, so 90 divided by 360, that is the same as 1/4. And you times that by pi, and then you times it by the radius squared, not times by 2, but squared. Sometimes we won't get just single shapes to solve, sometimes we'll have these composite shapes. So in the example given here, I have a base with a circle on top, kind of looks like a bullet. And I'm given the information here that this side is the same as that side, is the same as that side, and they're 5 centimeters, and I want to know the area. Well, what do I need to know to work this out? I can see a square here, so I can figure out that much of the area. I can just do 5 squared. So for the square, it's going to be area equals 5 times 5 equals 525. I also need to figure out what goes in here. How do I know? Well, I know the area formula for my sector of a circle. So that is the angle divided by 360 times pi times r squared. Now the angle, well, it's a semicircle. The angle there is 180 by 360 times pi times radius. How do I know what the radius is? Well, that side here has got to be the same length as this side here. If these are both 90 degrees, we've got a square, that's got to be the same length. So I can say that that one is going to be, the diameter is going to be 5 centimeters. So the radius is half of that, which means it's 2.5 squared. And if I do that sum, it's going to be a half times pi times 2.5 squared, and ultimately that is going to equal 9.82 centimeters squared. So now I know the area of the square, and I know the area of my semicircle up here, which is this. So I just add the two values together. So if I make some space for myself here, and just add the two values together, and I'll end up with 34.8 centimeters squared. The area of a shape like this can be easy to figure out too if you know the questions to ask. First question is, what do I need to know to work out this area? Well, I can try and make it into some shapes that I do know. Well, I've indicated here that it looks like I've got a rectangle for this part. A rectangle that is 4 by 7 meters. So I can do that. Equals 28 meters squared. And then I need to know what the I need to know the area for this triangle. So how do we figure out the area for a triangle? Well, we need to know the height. So the height is that distance there, and it's indicated to me that the total height of this shape is 10 meters. So 4 of those meters are taken up with this side. So I can assume that this length is going to be 6 meters. The base of the triangle is going to be the same as this length up here, so it's going to be 7. So I'm going to end up having 6 times 7. And that equals 42 meters squared. To find the total, I can just do 28 plus 42, which equals 70 meters squared. And that's the answer. So the whole idea is that if you see a composite shape, try to make shapes that you know out of them, whether it be semicircles, trapeziums. As soon as you start making them into individual shapes, you can do the individual formulas and then add them up together at the end to get the total area. So that's it for our brief look at area. If you need to revisit any of the formulas or shapes, go back to the start of the video and have a look at them and write them down somewhere. Hopefully this is all you need to complete all the activities for this unit as far as area is concerned. Cheers!